Okay, in this problem, they tell us that we have a 30-gram sample of benzene at 5 degrees. We need to heat that benzene all the way up until it reaches 40 degrees Celsius. They would like us to determine the amount of heat needed to accomplish this change. Now, the first piece of information that they give us is the melting point of benzene at 5.5 degrees Celsius. I really like to look at heating curves for these problems because they both show the temperature changes and phase changes that our substances might go through. Now, the melting point that distinguishes a solid from a liquid phase, that temperature for benzene occurs at 5.5 degrees Celsius. Now, our substance is below that. We're starting out not at 5.5 degrees, we're starting out down here at 5.0 degrees Celsius. So I know I'm going to have to heat that up. I also know that after my phase change, after I melt that sample, I need to bring it all the way up to 40 degrees Celsius. So 40 degrees presumably is below the boiling point of benzene. 40 degrees happens right around here while we're still in the liquid phase. So it looks to me like we're going to have to do three things. We're going to have to go through a temperature change, a phase change, and then a final temperature change. I like to calculate each one of these separately and then just tally all those energy changes together to get my overall energy change. Let's start off with the first one, the temperature change needed to heat solid benzene up. Since we have a temperature change, we can go ahead and start with our formula Q equals mc delta T. And in this case, we're talking about solid benzene. So this is the specific heat of the solid, which is given to us. Q equals, let's take our mass, that 30 grams, 30.0 grams of benzene. We're going to multiply by the specific heat of the solid, which is 1.51 joules per gram degrees C. And now let's look at our temperature change. We started at 5. To get to the melting point, which is at 5.5, all we need to do is increase our temperature by half a degree. So we're going to increase by 0.5 degrees Celsius. Now, if you go ahead and do all this multiplication and unfortunately keep one significant digit due to this temperature change, you end up with 20 joules of heat that's needed to accomplish the first temperature change. Now let's go ahead and look at our phase change. In order to go across and melt our benzene, we're going to need to use the heat of fusion here. The heat of fusion has been given to us in units of joules per gram. Because we're in joules per gram, we just need to go ahead and multiply by the mass in order to get the joules for that phase change. So for part 2, the heat is going to be the mass times our enthalpy of fusion. Q is equal to 30 grams, 30.0 grams, times our heat of fusion, which was 127 joules per gram. We're going to keep 3 significant digits in this answer. And if we keep 3 significant digits, we get 3,810 joules for that next part. Now let's look at the next temperature change. We're going to go from 5.5, the melting point, 5.5 degrees Celsius, all the way up to 40 degrees. That's another temperature change. Since we have a temperature change, we can use Q equals MCAT. So Q equals mc delta T. This time we're in the liquid phase, so we want to use the specific heat of the liquid which was given to us. Q equals the mass, 30.0 grams. The specific heat of our liquid benzene was 1.74 joules per gram degrees C. And now our temperature change. To go from 5.5 all the way to 40, well, that's almost 35. It's just under 35. It's 34.5 degrees Celsius. 34.5 degrees Celsius. Okay, so now if we go ahead and multiply those out and keep 3 significant digits, we get 1.80 times 10 to the third joules. All right, so we need the total energy change for the temperature change, the phase change, and the next temperature change. So all we need to do is add all those contributions together. If we add 20 joules plus 3,810 joules plus 1,800 joules, but this is all the way to the tenths place, 1.81 times 10 to the 3 joules. If we add all those up and keep track of our significant digits, we get an answer of 5,630 joules for that entire process. I hope that helps. Take care.